Welcome to another interesting set of questions. This time, our focus is on change of subject, an important topic for GCSE and middle school and high school students. We'll take up 50 questions and solution of some of them. You can pause the video, copy these questions, work them out, and watch my video to see how do we solve these questions.
Our approach, Engaging Minds, helps students think creatively and solve problems strategically. It helps them to connect with the context, visualize strategies, apply learnings, and bridge the gaps. Join Anil Kumar classes, gain confidence, and get ready for future. We develop mathematical and social skills for excellent performance of our students. The gift of education. I can be part of your success story, build strong foundation, ensure bright future. Join Anil Kumar classes, send an email on the address given here. Let us now enjoy the class with Abhinav.
I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. I have received many requests regarding this topic on change of subject or isolate variables. Here is a worksheet for you. In this worksheet, we have 50 plus questions. So we have 50 plus questions, and I have categorized the examples into 7 categories. I'll share with you all these questions now. You can, in between, pause and try them out, or you can make a note of these questions and practice later. I will also solve some of these questions to make you understand the techniques. So on the very first page, what you see here is type 1, which is linear type. So all the examples are examples where we have to work with a linear equation and then isolate the variable. The question here is, change the subject of the formula to the given in brackets. For example, distance is speed into time, very common formula, d equals to st. You need to isolate t. So what is t equals to? Simple as that. You can divide by s. So distance is speed into time. To find what t is, you can divide by s on both the sides, and you know that distance over speed is time. And that is how you have isolated t, which is distance over speed. So that is what we are trying to do. Second question, we need to isolate h from P equals to mgh, common formula for potential energy. C equals to 2 pi r, circumference, you want to isolate r. Y equals to mx plus b, you have to isolate x. Perimeter P equals to 2L plus 2W, isolate L. M equals to half A plus B, isolate A. Similarly, we have many examples here. Y minus 5 equals to minus 2 times x minus 3, isolate x. Now these are common formulae which are used in mathematics, and therefore this is a very important exercise. So I hope the very first page with 10 examples is clear to you. We'll come back to this and isolate variables or change the subject for some of them, just to give you an idea how should we be solving them. Now let me take you to the second page where we have type 2. And in type 2, what have I done is basically I have linears equations with fractions. Some students have difficulty in working with fractions, and therefore I have put them separately. So once you master level 1, you can move on to level 2 and then master these. Approach is very similar to what we had in type 1. And then we'll move on to fractions, which is normally called rational expressions, right? So type 3 is with simple rational expressions. As you can see, A over B equals to C over D, isolate C. That may become tricky at times. For example, in this particular case, you need to isolate X, and so could be slightly difficult as we move. So here we have 8 questions. Move on, and another set of type 3. Rational means fractions, correct? Now these are very important examples from test point of view. You know this formula. And in this formula, we have to isolate what U is. Sometimes they are given in this particular form. You need to now isolate what X is. Kind of difficult. And we will understand these strategies to do so. So I hope these examples are making sense to you. You can pause the video, copy and solve some of them. Now let's move on to the ones which have squares involved. Very common formula, A equals to pi r square, volume equals to 4 by 3 pi r cube, and so on, right? Well, this one is a cube. So others are all squares. Now when the square is involved, you have to do square root to isolate the variable or change the subject. So remember, we are going to change the subject, and the subject should be the one given in the square bracket, right? So it becomes tricky when you move on to some equations which have more terms involved. Here we have two varieties. Radius. In real life, sometimes when we talk about volume, height, radius, these are real numbers which are positive, non-negative real numbers. However, when you work with x and y coordinate system, you know x and y could take negative values also, and therefore there will be slight difference in solving these 6 questions than the others. Perfect. Here is another set which involves square roots. Very common equations seen, and you can practice some of these. That is the quadratic formula which you see here. You have to work with it in grade 10, but it's a good idea to isolate and get used to it. So what I've done here is taken another set with 6 questions, which I'm calling type 6, where you need to factor to isolate, right? So these are a few good examples for you. The last one in this series is kind of difficult, which is you need to complete the square to isolate the known. For example, this particular equation could be a challenge equation for some of you who are in grade 8 and 9. So you need to isolate x from the equation y equals to half x squared minus 3x minus 1. Well, that brings us to the end of the questions in our worksheet. In case you want to learn from me, you can always send an email on the address given here. So now, let me take some examples from the type 1, which is linear equations. We have already shown you how to do simple ones like d equals to st, and we'll take a few more just to give you an idea, rather get you started with, right? So now let me say v equals to u plus at. I need to isolate what a is, so I'm doing this one here. So I can take u to the other side and write v minus u equals to at, and then I can divide by t. So v minus u divide by t is a, and I've isolated a, or I've changed the subject to a, right? So now the subject is a. What is a equals to? A equals to v minus u over t. So that is how you're going to do it. I hope the steps are absolutely clear. So let me take another example from here just to give you more practice. Let me take this example, 8, which in this case is 2x plus 3y equals to 0. We need to isolate what y is. So I could take 2x on the other side. So that gives me 3y equals to minus 2x. And now dividing by 3, I can get what y is. So y is minus 2 over 3x. Does it make sense to you? So simple as that. That is our type 1 linear equations where we are isolating, right? Let's take some more examples from here. Which one? Well, let's take the last one. It is 5x y minus 5 equals to minus 2 x minus 3. Okay, let me rewrite this. You need to change the variable to x. That is to say, other terms should come on this side. So first thing is divide by minus 2. So we have y minus 5 divide by minus 2. That will give me x minus 3, correct? Now it becomes simpler. You can now write what x is. So x is equal to what? Bring 3 to this side. So we have y minus 5 over minus 2 plus 3. Is that clear to you? So that is how you could do it. Now, this particular statement can be written in many different ways. Well, when you have an equation, we could also call it a statement, since it can be read like that and interpreted, right? So I could also simplify this and writing x equals to what? We can take common denominator of, let us say, minus 2. In that case, we have y minus 5 and this becomes minus 6. Or I could write this as y minus 11 over minus 2. Now see, I could also change this sign to positive. In that case, we have 11 minus y over 2. You see that? And so this particular equation becomes our final answer, which is x equals to 11 minus y over 2. Do you see that? Sometimes we may need a lot of calculations, right? So we have changed the variable at this stage. However, that should be the final result. Perfect. So I hope you have understood these steps here. How do we isolate for the variables given when we have type 1 linear type of equations, right? So with that, let's move on to the other type, which is type 2. Okay, so type 2 is linear with fractions. So let's try to see how do we do these linear with fractions. It is similar to what we did just now. Let me take up the very first example, which is a very common example also. So we have c equals to 5 over 9 times f minus 32. What we need to isolate here is f, right? So we need to get what f is. So what should be my first step? Well, I could cross multiply, write 9 over 5 times c equals to f minus 32. Does it make sense? And from here, it is very clear I can isolate f. So I have 9 over 5 times c plus 32 equals to f. Do you see that? And therefore, I have isolated f, which is equal to 9 over 5c plus 32. Perfect. So that becomes my answer for the given question. Did you understand these steps? So when I do a couple of these examples with you, you go through them, right? You can always pause the video, go back to the examples, and then review. Perfect. Now let me just clear this and take up the next example. So till now, I hope all the things are clear, no difficulties. If there are, you can always put them in comments. Let's take the example here where we need to isolate a. The equation is s equals to ut plus half at squared. Since we need to isolate a, we do not want ut, so s minus ut is equal to half at squared. It was at squared. Okay, so from here, we do not need this half and t squared. So we have s minus ut times 2 is equals to at squared. And now we can divide by t squared. So we can write this as s minus ut times 2 over t squared equals to a, right? So that is how we could change the variable to a. So I'm using the two terms, change the variable, change the subject, and isolate variable, right? So in many parts of the world, we use change subject as written in this particular question, and sometimes we also say isolate the variables, right? So a different variable. So in this case, we have changed the subject to a, and now we know a is. A good way to write this is multiply by the numbers first, and then we have s minus ut over t squared. Does make sense to you? So that becomes our answer for the given question. So I hope these steps are absolutely clear. Another question let us take from this case. Let me erase this solution. We'll use this space to write down the solutions for these equations. Okay, so if you have any problems understanding, you can always contact me on the email address given here, right? And check our website for some new updates. Let us now do question number 7. Now, in question number 7, which is written right there, what is going to be my policy? So I'll say get rid of fraction. Get rid of fractions. So we have 2 and 3. So what is the LCM? Well, the LCM is 6. So I can multiply each term by 6. Let me do it here. So I can multiply this by 6 and that also by 6. When I do so, what happens? 6 goes 3 times with 2, and here 6 goes with 3 2 times. You get the idea. So I can now write down this expression as what? 3 times y minus 1 equals to minus 2 times 2, right, which is 4, x plus 1. Is this step clear to you? So once you cancel, you multiply this 2 with 2, you get 4, minus sign is already there. We need to get what x is, right? So in this case, we have to isolate and we have to get the x. Let me write x in the brackets. Let's open the brackets now. So, well, really speaking, you need to open and simplify. So we have 3y minus 3. That is the distributive property. When you open this, you get minus 4x minus 4. Bring x to the left side. It becomes positive 4x, which is equals to y is on the other side, minus 3y, and we have minus 4 plus 3. Now, we can rewrite this as 4x equals 2 minus 3y minus 4 plus 3 is minus 1. Dividing by 4, we get our equation, which is minus 3 by 4y minus 1 over 4. Do you see that? So we have isolated x, or we have changed the variable, or changed the subject, I should say, to x. So change subject x now is equals to minus 3 over 4y minus 1 over 4. Is that clear to you? So that is how we could do these kinds of questions. So in this part of the video, I will conclude with type 2, where we have taken linears with fractions. Now, in the next part of the video, you will see how we can change the variable when rational expressions are involved. So I hope all this makes sense to you. If you want to learn from me, you can always send an email on the address given, and if you have doubts, you can put them on the comments. I hope it all makes sense. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time. Now let us continue with type 3, which is simple rational expressions. How do we isolate variable, or how do we change the subject when we are given rational expressions as shown here? Now here we have A over B equals to C over D. We need to isolate C. So the strategy basically is cross multiply. So when you cross multiply, what do you get? Let me show you here. We have A over B equals to C over D. So when you cross multiply, we get A times D equals to B times C, right? Now in this case, we want to isolate C. So if I want to isolate C, I will only divide by B, right? So I get A dot B divided by B. We have isolated C, correct? Well, if you want to isolate D, in that case what? In that case, from here, D is equal to B times C divided by A. So you can actually crisscross and get the result. You can change the subject to what required by cross multiplication, just as we have done. Does it make sense? So that is how you could do it. Now let's take another example here, which is A plus B plus 1 equals to C over B. So we are now going to take 3. So the example here is A over B plus 1 equals to C over B, and we need to isolate C. So we need to isolate C, which is kind of isolated. The only thing is we have to multiply that expression by B, right? So we could also go one more step here, taking B common. And we have A plus B in the numerator equals to C over B, right? Now, C is equals to B times A plus B over B. Now this cancels, and therefore we could write C as equals to A plus B, right? So I could write C as equals to A plus B, and that becomes the changed subject. So that is how easily we could do example number 3. Perfect. Let's take some more. Okay, so let me take 7 now, which is A over A plus B equals to 2. So we'll cross multiply, that is the strategy. So that gives us A equals to 2 times A plus B. Expand, so we get A equals to 2A plus B. Now since we want B to be isolated, we'll bring this 2A to the left side, right? So we could also write this as B equals to A minus 2A. And that gives us B equals to minus A. Does make sense to you? So that is how we could easily do the change of subject by using cross multiplication when we have an equation which is kind of a proportion. Is that clear to you? Perfect. So we have done all this. Let me take the last example from here, which is 6. You can also pause the video and answer the question. 6 is 2 over x plus 2 over y equals to 5. We need to find what x is. So what I'm going to do is I'm going to retain 2 over x here and take the term 2 over y to the right hand side. And so we have 2 over x as equal to, let's take common denominator of y. And then we have 5y minus 2. Now we need x. We can flip it, right? So if you flip it, you get x over 2 equals to what? You get y over 5y minus 2. And now we can get what x is by multiplying both sides by 2. And therefore, we have x is equal to 2y over 5y minus 2. Does it make sense? So, that is how you can change the subject when we have rational expressions involved. So I hope these steps are absolutely clear. Let's take some more examples on this topic, since it is indeed a very challenging one sometimes, right? Okay, so we'll take up example 11 now, which is kind of difficult. But before that, let me take 10. Okay, let's take 10, which is x minus 3 over x plus 1 equals to y over 2. We need to isolate x. So the idea here is cross multiply. You see, these are kind of proportions. And just cross multiply, so you get what? You get 2 times x minus 3 equals to y times x plus 1, correct? Now, we can open the brackets, we get 2x minus 6 equals to yx plus y. We need to isolate x, bring x together. So we have 2x minus yx equals to y plus 6. And you can factor out x now. So we get x factored 2 minus y equals to y plus 6. And now we get the answer, which is x equals to y plus 6 divided by 2 minus y. Does make sense to you? So that is the strategy to work out these examples. Perfect. So you can continue practicing with these examples. In case you have any difficulty, you can always send an email on my email address given. Have a good look at this solution. We'll take up the next question now, where the strategy is same, that is cross multiplication. However, we'll first write that statement in terms of proportions, and then we'll cross multiply, right? So we have here x minus 3 over x plus 1 equals 2. So y over 2 plus 1. So we can take a common denominator 2 and we get y plus 2. Do you see that? Now we have a proportion, we could cross multiply and do it as we did the previous example. So we get 2 times x minus 3 equals to x plus 1 times y plus 2. So we get here 2x minus 6 equals 2. Now we should get 4 terms and then we'll combine them. So we get xy plus 2x plus y plus 2. Since we need to isolate x, I'll bring the x terms to the left side. So we have 2x minus xy and again 2x. So 2x and 2x cancel. Do you see that? And we have on the right side y plus 2. And we are taking plus 6. So here we get 2x, 2x cancel. So we have minus xy equals to y plus 8. And what is x equals to? Well, you can write down your answer, which is x equals to divide by minus y, or you can write minus y plus 8 over y. Is that clear to you? So that is how you could actually isolate x from the given expression. Perfect. So in the next part, we will see how do we work with squares and square roots. I'll end the video at this stage. In case you need help from me, you can always contact me on the email address given here. Thanks for your time and all the best.